All right. In this video here, we're going to talk about 7.3, which is confidence intervals for the mean when the population standard deviation unknown. So in the last section, we saw how to figure out the intervals when it is known. In this case, we're going to talk about when it's unknown. So in our third vector, for mean population standard deviation. Most of the time, all right. So most of the time, population standard deviation is unknown. So it is estimated by the sample standard deviation, which is again lowercase s. When the sample standard deviation is used, especially when the sample size is small, critical values greater than the value of the z-score of the alpha divided by 2. Remember, those are the wings on each side of where I think the range of my mean will fall, are used in confidence intervals in order to keep the interval at any given level. These values are taken from the student t distribution, most often called the t distribution. So this is going to be another part of your charts in the back of the book on Appendix A that we'll use throughout this process. So the t distribution, the assumption required to use the t-distribution, samples must be, again, randomly selected. So this is simple randomly samples. The population from which samples are selected must be normally or approximately distributed, or the sample size must be 30 or more. So remember, if it's less than 30, we need to know it's normally or approximately normally distributed, or if it's over 30, it doesn't matter if it's normally distributed. Properties of the t-distribution. The t-distribution is bell-shaped. The t-distribution is symmetric about the mean. The mean, median, and mode are all equal to 0 and are located at the center of the t-distribution. The curve approaches but never touches the x-axis. Very similar to what we've already seen with normally distributed data. The standard deviation is greater than 1. The t-distribution is a family of curves based on degrees of freedom, which is related to the sample size. And I'll talk about how to find degree of freedom. As the sample size increases, the t-distribution approaches what the standard normal distribution would be. Right, so you can kind of see that this is a normal z curve. This is a degree of freedom of 20. This is a degree of freedom of 5. So the more degree of freedom, meaning the larger my sample size, the closer to the actual curve I would get. So the definition of degree of freedom are the number of values that are free to vary after a sample statistics has been computed. The degree of freedom, also known as DF, for a confidence interval for the mean is found by subtracting 1 from the sample size. Thus, to find the degree of freedom is simply n minus 1. So you take whatever the sample size is and subtract 1, and then you have your degree of freedom. You would need the degree of freedom. This is why you would need to find the degree of freedom, because then you take the critical values at t alpha divided by 2 for the t distribution at a specific confidence interval, and degrees of freedom are found on Appendix A, Table F. So this is what we'll be using. Will not be using technology. Right, so make sure you have table E and table F dog tag so that you're able to easily find it in your book. And of course, on the assignments and tests, I'll have the formula chart for you as well to be pulled up. All right, but then this is again everything that you would need to know. And once you find the degree freedom and you know your confidence interval, you just kind of follow the chart. So with that said, let's look at what the chart looks like in your textbook. So this is a table FT distribution. So you would do n minus 1 to figure out your degree of freedom. And then depending on your confidence interval, so let's say I wanted a 95% confidence, you then need to determine if you want a one tail or two tail. A one tail would simply be you want to be greater than the values, or a two tail, you would want to be between the two values. So therefore, this is what you would go with. Again, depending if you're given the alpha, or you're given the confidence interval. So I can give you the alpha, tell you it's a two tail, then you would locate the value here. I could give you the alpha, say it's a one tail, give it here. Again, depending on the language is how I tell you. Or I could give you the confidence interval, and then you would look here. So you take the degree of freedom, figure out what it is you're looking for, and then you go down, and then that would be the Z-score for that value, right? It's called a T-score, but it's going to be pretty close to the Z-score. And you'll notice the larger it gets past 25, I think it then goes to 30, then 40, then 50, and so on and so on. All right, so let's do an example with that. So in example 3, we're asked to find, come on now. All right, the T-score. So finding the T-score value for a 95% confidence interval for a sample size of 25, sorry. So you would find the degree of freedom, which would be n, which is 25, minus 1, which is 24. So then you would go to 24, which is right here in the left column labeled degree of freedom. And then you would go to 95 in the row labeled confidence interval. So let me scroll back up. There you go. So 95 is the third one. Okay. Let me come back down. All right. So I would go to 25 minus 1, which is 24. Go to 95%, and there's your score right there. So you would just say it is 2.064. And the larger your sample size, the closer of a T-score becomes to the Z-score. Ready? All right, so a formula for specific confidence interval for the mean when the population standard deviation is unknown would be this. So again, it's pretty similar to what the formula was already. The only difference is you would use a T-score because the population standard deviation is unknown, and you would use the sample standard deviation. All right, so again, you only need T-score if the population standard deviation is unknown. Once you learn both of these, they'll be kind of interchanged throughout the homework and the tests and stuff like that. So you need to know when to use them. All right. So again, and again, the final degree of freedom is n minus 1. So let's do an example. All right. So example 4 is dance company students. We'll do a couple examples. All right, so let me scroll down a little bit. So this one says the number of students who belong to the dance company at each of several randomly selected small universities is shown here. We want to estimate the true population mean size of a university dance company with 99% confidence, and the data are listed below. So here's our sample of our data. So the first thing we need to do is find our sample mean and our sample standard deviation. So what I'm going to do is I'm going to pull up my calculator, and then we will work on this together to be reminded on how to use the calculator. Again, I highly recommend using the calculator to do this. Okay, let me make sure I'm sharing the right screen. All right, here we go. All right, so remember, we're going to go to list and spreadsheets, and then we're going to type in our data. So this is 21, 25, 32, 22, 28, 30, 29, 30, 47, 26, 35, 26, 35, 26, 28, 28, 32, 27, and 40. How many are we supposed to have? Number of students who belong. Actually, let's just count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, 19. All right, cool. So we got all the right numbers. Always check to make sure you have them. Now remember, you would then go to menu, 4 for statistics, 1 for stat calculations, and we're doing 1 variable statistics. You just hit OK, and then you make sure that the A is selected, or you could give it a name and then make sure that name is selected, and then just put your results next to that column. So I'm gonna put it in B. So when I scroll up, I get my results. So remember, what I'm looking for is the sample mean. All right. So remember, the X with the bar over it is gonna be my sample mean. So when I come with my information, let me switch over. I now know that my sample mean is 29.8. Again, you go one more decimal past what you're given. And then my S, again, I want the sample one, or the population standard deviation, not the sigma, so the lowercase s. And in that case, that would be 6.176 is what we can go with. I think you go with 6.8 and be just fine. Second, we find the degree of freedom. Well, my N was 19, so my degree of freedom would be 19 minus 1, which in this case is 18, right? So that's all the information we did. Then we need to calculate our information. And so I'm actually gonna, I know the next one just says and calculate this part right here. So I'm gonna write it here so that all of our information is there. Or maybe I could do this. Hold on, let's see. Just do that. There we go. I can put all of it now in one. So again, this was 29.8. This was 6.176. Degree of freedom, again, N was equal to 19. So this would be 19 minus 1, which is 18. So to find this guy, I need to go find the guy. So I need to go to 18. And then I'm looking for, so I'm going to trash this real quick. I'll come back later. I'm looking for 19 and 99% confidence. So when I come back up here, so I would then go to right here, there's 19 right there. And then at 95% confidence, it would be 2.093. Oh, yeah, no, my bad, 18 degree of freedom. And it said 99. So 19 minus 1 is 18, and then I would go to 99%. I thought it said 95. And then it would be 2.878. So there is your T-score located right here. So once you have it, then you can now go back to that example. So again, I now know that this is, again, 2.878. Now that I have this information, now I can calculate this. So this will be 2.878 times 6.176 divided by the square root of 19. When you type that into your calculator, it comes out to 4.08. Then you're going to add and subtract this value to your sample mean to create a confidence interval. So you would take your 29.8 minus 4.08. And again, this is where we're assuming our population mean would fall. And you would take 29.8 plus 4.08. And when you do that, you'll end up getting 25.72. And then this would be 33.88. So again, with my sample mean of 29.8 with a population of 19, population standard deviation was not given to me. I only could calculate my sample standard deviation. So then I must use a T-score to help me get my information. Same type of formula as the Z-score formula. I just take that, multiply it to the sample standard deviation divided by the square root of my sample. and then add and subtract that from my population mean. So I'm basically stating that the population mean would then fall with 99% confidence between 95.72 and 33.88 with the information I have been provided. All right, let's do another one. I just do the work up here. Let's get myself enough room. There you go. Okay, so in example 5, we're going to be talking about hospital noise levels. So for a random sample of 24 operating rooms taken in a hospital study, the mean noise level was 41.6 decibels and the standard deviation was 7.5. Find the 95% confidence interval of the true mean of the noise level in the operating room. So here we go. So a random sample of 24, that's my M. It's less than 30. Taken in a hospital study. The mean noise was this. So this is my sample mean. And the standard deviation, again, for the sample. So this would be S. And we're going to find the 95% confidence interval of the true mean of the noise level in operating rooms. So the things I need to know is I need to know, I got my mean, I got my sample, I got my standard deviation, I got my sample, I need my Z-score. So this is the only thing. Oh, sorry. I need my T-score since I do not know population standard deviation. And I need to know degree of freedom, which would be 24 minus 1, which is 23. So I need to go 23 and 95. So I'm going to trash this. We'll come back. So 23 and 95. Okay, so I go to 23, which is actually right here. Go to 95, and I see that my T-score would be 2.069. So then I take that, and I come back to my work. It is right here. Oh, I need to lower it one more. There you go. So again, my T-score was 2.069. Once I have this information, now I just take and I find this guy. So this would be 2.069 times 7.5 divided by the square root of 24. And we do that, we actually get 3.17. Then we take that and we add and subtract that to our mean. So I'm going to take, and I'm going to write it, I'll write it right here. The mean was 41.6 minus 3.17, and then 41.6 plus 3.17, and that comes out to 38.43 and 44.77. So basically, I'm stating that with the information provided, I think that the population mean of all operating rooms would fall between 38.43 and 44.77 with a 95% confidence. Or I'm also stating that any sample means I'd take would have to fall between this with 95% confidence. All right, so that pretty much wrap up trying to find the confidence interval when the population standard deviation is unknown. All right. If you need more questions or answers on that, just let me know, but I'll see you in the next video.